If you've watched many of my videos, you've probably realised I don't write a script for them. I just video as I progress, or I'll just start talking and see where it leads, and often it depends on what I find and what's required to effect a repair. And this is one of those videos that hasn't really turned out the way I intended, and I've decided to change the general tack for it. Now, in the previous videos in this series, in which I'm trying to repair and restore a PDP11-34 vintage computer, I've gone through the machine, stripped it down, and I put a backplane on the bench, connected it to the power supply, which I've been through, and then I connected the console controller, got that working. It wouldn't run at first, and then I was using that setup, the backplane, power supply and console, to go through the other boards. So I went through the serial card, then went through the various other cards to check them, make sure they were fine. So it was all working okay. The console was working. I could use it to test other cards. I'd done some provisional testing on the backplane. I'd also done some provisional testing on the RAM card. And the RAM card, the way I tested it, because I don't have the system fully up and running yet, is I wanted to make sure all of the chips on it were fundamentally working. There's quite a few chips on it. We'll have a look at the card in a minute. But also I wanted to try and make sure that all the address and data lines were working. So I would write to address 0, for example, write a 1 to that value, write a 2 to the next address, then a 3, then a 4, etc. And when I went back to examine it, if any of the address lines were tied or weren't working, then of course we'd end up with either the wrong values or duplicates, and you can generally figure out which particular bits are not working. But the RAM appeared to work. I could test all the various devices that were on it, and I was getting the right value for each of the ICs. Each of the data lines and address lines seemed to be toggling. So I had the RAM card working, I had the console, the serial card, I tested the bootloader that I do have, the terminator, and that meant I had enough cards to actually move on to the CPU cards, and that's the reason I do the testing in this order. I'm trying to get essentially a platform put together that I can test the CPU cards on, because they tend to be the ones that are more complex to get working. So I had the console, the backplane, serial card and the RAM up and running. So I then fitted the two CPU cards. In fact, I did them one at a time, and this is where this video kind of changed tack. The original intention was to go through these cards in the same way I had the other cards, one at a time. You can do quite a lot of testing using the console. You can write to the various registers in the cards, you can perform certain functions, and you can do quite a lot of extensive testing that does test quite a lot of this card. And the same with the second CPU card. There are two of these cards. One's a data path card that selects what the CPU is effectively connected to, depending on the function it's currently performing, and then you have the control card that has the ALU and that sort of thing on it. But you can do a lot of testing, but what I found on this particular card, I did find a few faults, but I'm not going to show the faults in this video, which is originally I intended to, but I've decided not to. And the reason I've decided not to show it in this is I realised as I started trying to edit the video that it doesn't make a lot of sense, some of the descriptions I was making, unless I fully explain the internal workings of the CPU. So I will show those repairs at some point, but I've decided to create a completely separate series of videos that detail an explanation of the CPU system in this machine. It is quite interesting, and once I've gone through the inner workings of it, the faults I found will make far more sense. For anyone that is familiar with this, just a quick rundown of the faults I found. When I plugged the data path card in, on its own, but with the console and the RAM, I found that I couldn't talk to any of the RAM locations, or at least not reliably. I could still read and write the register in the console, but not the RAM. And obviously the difference there is the bus, the unibus, is not used or directly used to send data to the console controller. And what I found was a couple of the bus drivers were failing. Some of the lines, some of the address lines were kind of being pulled low all the time. They weren't being released by the CPU. So I fixed that. I then found I couldn't talk to a couple of the registers in the CPU. I couldn't read and write them. Or at least I couldn't read them. I don't know if I was writing them or not at the time, because I couldn't read them to check. And that was a couple of multiplexers had failed, and then finally I had an issue with the ALU. It was not giving the correct results on certain rotation commands, and that turned out to be a shift register that wasn't working the way it should. So I had 5 ICs, and that was it. That's all I found so far on both of the cards, so that was quite good. And the intention was to put the cards then into the backplane and try and boot the machine up. It hasn't been booted yet, so I want, at least not the main processor, so I wanted to try and see if I could get it working. And the way I was going to do that was to put the bootloader card in, set it up to use the remote terminal, and see if we could boot it up and run a short program. But unfortunately that meant changing the order that some of the cards were in. And when I put the cards in the correct order, that's the order that they were in when I got the machine, I included the bus grant cards, terminator card, etc. So it's all set up the way it should be. But when I tried to enter the program, I found that I couldn't enter it correctly. It looked like there was an addressing error for the RAM card. So for example, I then tried to test it by entering values 1, 2, 3, 4, 5, 6, 7 in the first 7 memory addresses. But what I ended up with instead of that sequence is I ended up with 567, 567, 5. And if you're familiar with this sort of system, then you'll know that's an indication that bit 2 was stuck, address bit 2. So I thought the RAM, and it did that throughout the address range, so if I went to address 1000 and tried the same thing, I'd get exactly the same result. So it wasn't an individual RAM chip that had failed. So I decided to move the RAM card back to the front so I could access it. At the time it was at the back of the stack of cards. So I took out the CPU cards, I took out the serial card, and took out the bootloader card. So all I had was the RAM card and the console controller card and the terminator. And it then didn't do the same thing, so let's get these out of the way. So when I put the RAM card back in front of the console controller, it worked fine. I was getting the correct values from those memory locations. So it looked like there was an error with the backplane. So what I then did was start following the lines on the backplane from the unibus slots up to the extender slots that the memory card was using. And most of the memory information comes direct from the unibus slots. So I started looking at this, actually found a broken wire wrap wire on the underside of the backplane, and it was on address line 2, so hopefully it was just that was faulty. So long-winded explanation as to why I won't be showing the faults in this particular video for the CPU card. What I want to do is try and get the CPU, the main CPU, to boot. I'll come back and do a future video series and show the faults that I did find with the 2 CPU cards. But I've been through them. I think the RAM card is working. I think both of these CPU cards are working at least well enough for the machine to boot up. So I'm going to get this reassembled. I'm going to plug the backplane back onto the power supply. So what I will be inserting are the 2 CPU cards, a grant continuity card, the console controller card, a boot loader card, the serial port card so I can use a remote terminal, the RAM card, 2 more Grant continuity cards, in fact 3 more, and then the Terminator card at the end. That should be enough for the system to boot up, and we should be able to boot up to a command prompt on the remote terminal. So that's what we're going to try and do now. I don't know if this will work. I haven't tried putting the RAM card back into its proper slot yet, so we'll see what happens. I've plugged all the cards in that I intend to use for this testing. I've got the 2 CPU cards. As I said, I found a few faults on those when I was using the console to test them. I've then got the interface card for the console itself, followed by the serial card. I've got a bootloader card, and then the RAM card, and all the empty slots have Grant continuity cards fitted, and of course I do have the Terminator card. We've got the M7859, M7856, the boot loader card is the M9312, the RAM card, not sure who made that. I don't think it's a DEC part. And by the way, I say DEC, I get a lot of complaints from people that seem to think that I should say DEC. I'm specifically saying DEC so that anyone that wants to Google what I'm talking about will actually be able to find some information on DEC. It's an abbreviation for a company that manufactured this. If you don't like it and you'd rather I say DEC, it's unfortunate. I'm doing this to make the videos as clear as possible for anyone that has not come across the word DEC in relation to a manufacturer. So the manufacturer abbreviation is DEC. That's why I'm saying it. It's not to wind anyone up or annoy anyone, it's just because that is what is going to make it easiest for people to Google and find information if they want to. So as I say, I don't know who made this RAM card. All the empty slots have the bus Grant continuity cards fitted. The other thing I've done, because I don't have the main fans fitted, and it wouldn't do a lot of good anyway, the supplies aren't really going to overheat with just these cards in. It's mainly the cards themselves that need some cooling, so I've just put a 12 volt fan down at this end, and in fact that's probably what I'll use when I reassemble the entire system. I'll keep the original fans, but I'll make up some adapters to fit quieter fans. It does not need the huge airflow. The fans that are fitted have a huge airflow, and they're needed if you have a fully populated machine and you're running in a very hot environment. Bear in mind that this cabinet sits inside a rack and it can get extremely hot in there. It's got other equipment, but depending on how you're running it, you don't need that amount of airflow. So you can do one or two things. You can either put a controller on the fans, slow them down, or you can just put quieter CPU style fans in. Also, if you've got a cabinet that's only got the first backplane in, these huge fans are sucking air through. The air is going to take the path of least resistance, so all the air will be missing most of the boards anyway. It's not going to go down this tortuous path between the boards, but it can just flow through the big open space. So if you want to keep your boards nice and cool, put an empty cardboard box in the open space that just about fills the space, and then that will increase the airflow through your cards by a factor of 4 or 5, so you get much more air flowing through the cards. Otherwise the air just goes down the open space and straight out the back of the machine. Okay, so we've got the cards in. Enough waffle. I've got this connected to a remote terminal. Normally I'd plug it into an actual terminal, an ADM3 or something like that, but I can't get everything into the same shot. But I can bring the terminal up into the corner of the screen. Okay, so we're ready for the what will hopefully be the first boot up in quite a few decades for this machine, or it could be the start of a very long fault finding process. I go through the process I do step by step. I get the cards working in a certain order, specifically to make this step as hopefully trouble-free as possible, but there are so many things that can stop these systems working that it's always a bit of a lottery the first few times you get to this point. So without further ado, we'll try and turn this on. Hopefully we're not going to see lots of magic smoke being released, but let's give this a go. And as you can see on the terminal, it does appear that it's at least partially booted. I'm now going to start up the cooling fan to make sure these boards don't overheat. I've got it turned down to its 12 volt fan, but I'm running it at 9 volts. It will be enough to keep them cool for this testing. So excuse the fan noise, but I need to have some airflow. You might not think it will do much, but if I get a bit of tissue paper here, you'll see that there's quite a decent airflow coming down through the boards and out of the back of the machine, so that will be quite sufficient to keep these boards cooling for a short amount of time while I perform this test. So as I say, I'd been to this point before, but I couldn't get the RAM to behave. It wasn't giving me the right information, so we'll try that again. So we'll go through and get back to the correct point. So what I'm going to try and do now is enter the values 1 through 7 into the first 7 memory locations. So we'll start off at memory address 0 and we'll put in a 1, deposit that, 2, 3, etc. Okay, so I've put the values 1 through 7 in the first 7 locations. We'll go back to memory address 0 and we'll examine the value there. Before I was getting 567, 5675, which was wrong, so hopefully this time we'll get a 1 at this address. And indeed we do, so that's a good start. Followed by 2. Okay, so that's looking much better. If we keep going, we'll just get the values that were reset in memory when we boot it up. So that's a good sign. It's now doing what it was supposed to. Okay, so what I'm going to do now is the same thing, but starting at address 1000. So we'll put 1000 in as our start address, and now we'll try entering the same values into the first 7 locations. Okay, so we'll go back to address 1000, examine the values. Okay, and that's looking good as well. So looks like the RAM is now working. So it appears just some broken wires on the backplane. It's fairly unusual. I haven't really come across that before. I've had it very rarely, but when there was obvious signs that it had been damaged. But this didn't appear to be damaged. It's just a broken wire that presumably has just broken through fatigue. It cracked and was no longer connected. Okay, so what I'm going to do now is enter a short program through the console, and we'll see if we can actually run the processor. It's kind of running at the moment, but it's not running any actual program. So I'm going to enter a very short test program to display one of the registers on the console, and we'll see if it actually works. So just bear with me. I'm just going to enter a very short program. Okay, so I've loaded the program. It's only 10 instructions, so very quick and easy. All it in theory should do is repeatedly print out a register value on the terminal. So if we keep an eye on the terminal, we'll go back to address 1000, which is the start address that we want, and we'll try and run and see what happens. Okay, as you can see, it's actually running. We're getting something on the terminal. Won't be much, it's just basically displaying garbage because it's just repeatedly displaying one of the registers on the CPU. So that's as far as I'm going to go in this video. Bit of an odd video, it was a bit disjointed. As I said, I'm never quite sure how these videos are going to turn out when I start them, but the main thing I wanted to achieve in this video was getting this system, this CPU system, to boot up, and it's the first time it's running in many years. So we're making good progress. As I say, just a few faults with the 2 CPU cards, quite easy to sort out, and a bit of an odd fault with the backplane. but we are now up to the point where the system seems to be able to run actual code. So that's a good sign. It means we are making good progress. Everything at the moment seems to be working. What I'm going to do now is I'll go away, I'm going to write a memory test program, fairly short, and it's just going to walk through, and I'll leave it running for a while and make sure it behaves itself. And so in the next video we'll move forward with this. We're, as I say, getting fairly close now to having the entire processor up and running. And the next thing I want to install is the floating point card and see if that works. We can then fit the cache memory card, and that will be the entire CPU reinstalled, but we may have a way to go before we get there. If you're interested, by the way, the amount of power this is drawing at the moment is about 220 watts, so it's not drawing a huge amount of power, so these things don't get roasting hot unless the fans stop completely. The regulator on the main 5 volt supply is getting warm. I won't say it's getting hot. It's got a bit of airflow, but if you turn the fan off completely it would fairly quickly get extremely hot, so it does need a bit of airflow. Okay, so that's it with this video. Obviously we're making some progress. We're getting close to being able to put this back in its cabinet. Just a couple more cards to go.